Algebra 1, we're splitting the first lesson into two parts. For this first part, our objective is to be able to distinguish between sets of numbers. Let's keep it real. So, what are the sets of numbers? We're talking about real numbers. It's in the title of the lesson. But what does that even mean? Well, let's look at numbers and how they're grouped together. So you see here in yellow, we have what's called the natural numbers. Natural numbers are a group, and this is the symbol that stands for the set of natural numbers. It's your counting numbers, 1, 2, 3, and so on. This ... means and so on. Now, the natural numbers is the smallest complete set of numbers. Even though it goes on to infinity, it's still complete. And then our next set of numbers called the whole numbers. It doesn't really have its own notation like natural numbers, but it basically is the natural numbers, and then it includes the numbers 0. These are all whole numbers, no fractions or decimals. Then we have the integers. The integers get their own special symbol. It says fancy looking Z, and they include negative numbers. And they're all whole numbers again, so no fractions. Inside the integers, you see you have the whole numbers, and inside the whole numbers, you have the natural numbers, which means that all natural numbers are also integers. Next up, we have rational numbers. Rational numbers get the letter Q. Looks like that. It's a special Q. That stands for the set of rational numbers. Rational numbers are all these numbers that can be written as a fraction. Even negative 2.65 can be written as a fraction. Here we have a mixed number, which can be rewritten as a fraction of 25 over 4. So rational numbers are written as some integer, so we'll do little z, divided by another integer. Okay? 2/3. 2 is an integer, it's a member of this group, and 3 is also an integer, it's a member of this group. When I use the division bar, which is called the vinculum, to separate them, to show division, I'm creating a rational number. Out here we have irrational numbers. Irrational numbers get the special symbol I. Looks like the Roman numeral 2, and there's like a little dash that goes between them. Rational numbers cannot be written as some integer divided by another integer. Rational numbers cannot be represented as a fraction. This is no, they do not do that. A couple of famous examples of rational numbers are pi and the square root of 2. Those are two of the most famous. Also, you can have the square root of, you can have the square root of 3, Euler's constant, square root of 11, or 5 plus the square root of 17. These are all examples of irrational numbers. They cannot be written as a fraction. And so there's no overlap. That's why the irrationals are over here by themselves. There is no overlap between natural numbers, whole numbers, integers, rationals, and the irrational numbers. But all of them are what's called real numbers. Okay? And real numbers get this special looking R. It's got two little uprights on the backside. So these are the type of numbers that we're going to discuss and use throughout this unit. And so I said some words. I said set earlier. Maybe I said element. These are some vocabulary words. And this is in your book. I believe it's on page 5. And so here they give an example. They say a set of numbers from 1 to 10, which elements are in both the subset of even numbers and the subset of multiples of 5. What are these words? So first we have set. Set is a collection of objects. Okay? In our previous slide, those objects were numbers. Sometimes they were whole numbers or negative numbers or fractions. Okay? A set is a collection of objects. In this case, we name our sets, and then here we have A is the name of this set. And we show that it's a set by using these squiggly brackets. And we write all the elements inside it. Right? An element is an object inside the set. So element is an object in a set. one object. So if I have elements, I have many objects. So I say set A is the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A subset is a set that is inside another set. So subset is a set, which is a collection of objects, that is inside another set. Usually this other set is bigger than the subset, okay? Usually. It can never be, the subset can never be bigger. It's either smaller or it can be the same size, but usually the subset is smaller. So here we have another set, B, and in it are even objects, 2, 4, 6, 8, and 10. And then we have an even smaller subset, 5 and 10. Now if you notice, 2, 4, 6, 8, and 10 are all inside set A. So that means, yes, B is a subset of A. Now if we look at C, I have just 5 and 10. Those are my two elements. 5 and 10 are also inside set A. So that means, yes, C is a subset of set A. That's really all. There's no assignment here. This is just for you to understand some of the language we're using, set, element, subset, and the language of natural numbers, integers, rational numbers, and irrational numbers. This should be review from previous math classes. If you have any questions, you know how to get a hold of me. Let's move on.